Hello, we're going to talk about 3.6 implicit differentiation and the related rates today. We're going to start from implicit differentiation or differentiating implicitly. Let me just remind you the chain rule first. If y is a function of x and h of x equal to y to the n, then the derivative of h with respect to x, h prime, is equal to n times y to the n minus 1 times dy over dx. There are two types of functions. One is called an explicit function, where y is written in terms of x explicitly, like y equal to x squared. And the other is called an implicit function, where y is not written in terms of x explicitly. Instead, they are related by equation, like x squared y cubed plus 6x squared equal to y plus 12. So how do we take the derivative in this case? How do we find the dy of dx for an implicit function? It turns out that we need to take the derivative with respect to x on both sides of the equation, treating y as a function of x, and then solve for dy over dx from the resulting equation. So let's do an easy example. Let y be a function of x and y squared equal to x. Find the dy over dx. So this is an implicit function. So we start by taking the derivative with respect to x on both sides to get 2y times dy over dx on the left. Remember, y is a function of x, so we need to use the chain rule. And on the right, we just get 1. So we can easily solve for dy over dx to get 1 over 2y. Let's do a more complicated example. In this example, we got the equation of x squared y cubed plus 6x squared equal to y plus 12. So that's just the example we started in this section. Find the dy over dx. So again, we take the derivative with respect to x on both sides of the equation. On the left, we got the x squared y cubed as the first term. Because y is a function of x, so this is a product of two functions, x squared and y cubed. We need to use the product rule. The product rule says the derivative of y f times g is equal to f prime g plus f g prime. So we get dx squared over dx y cubed plus x squared times dy cubed over dx plus 12x equal to 1 times dy over dx. So we are using the chain rule on the right. And so now we get 2xy cubed plus x squared 3y squared dy over dx plus 12x equal to dy over dx. Now move all the terms with dy over dx to the left and the other terms to the right. We get a 3x squared y squared dy over dx minus dy over dx equals negative 2xy cubed minus 12x. Factor dy over dx from the left, we get 3x squared y squared minus 2. And then we divide by that on both sides. So we solve for dy over dx to get negative 2xy cubed minus 12x over 3x squared y squared minus 2. You can multiply negative 1 on the top and the bottom at the same time to get 2xy cubed plus 12x over 2 minus 3xy x squared y squared. Now let's talk about the related rates. Suppose x and y are two quantities that depend on a third quantity t. So both x and y are functions of t. And we know the relationship between x and y in the form of an equation. Can you find the relationship between the rates dx over dt and dy over dt? So it turns out that we can use the technique of implicit differentiation to solve this problem. So let's do a simple example. A study prepared for the National Association of Realtors estimates that the number of housing starts in the Southwest, N of T in units of million over the next 5 years, is related to the mortgage rate, R of T, in the units of percent per year by the equation 9n squared plus r equal to 36, where T is measured in years. So this is the equation relating the housing starts and the mortgage rate. What is the rate of change of the number of housing starts with respect to the time when the mortgage rate is 11% per year and is increasing at the rate of 1.5% per year? So we are given the rate for change of the mortgage rate, and we need to find the rate of change of the housing starts. So we solve for n first from this equation. So the equation is 9n squared plus r equal to 36. And R is 11 in the units of percent per year. and dr over dt is 1.5 in the units of percent per year. So we can solve for n from this equation to get n equals square root of 36 minus r over 9. Plug in 11 for r, we got the n equals 5 over 3. And to get the rate of change of n, we just take the derivative with respect to t on both sides of the equation to get 18n times dn over dt. Again, n is a function of t, so we need to use the chain rule. Plus dr over dt equal to 0. And we can easily solve for dn over dt to get the negative 1 over 18n times dr over dt. Then we just plug in 5 over 3 for n and 1.5 for dr over dt to get the dn over dt equals negative 1 over 20 or negative 0.05 millions per year. So this is a decreasing of housing starts because the increasing of the mortgage rate. So that makes sense. So that's the end of this section.